Welcome. In this session, we'll learn one of the most important topics in Matlab. That's how we do plotting in Matlab. Let's start. Let's open Matlab. This is Matlab. Now, before we start, we must remember every variable in Matlab is stored as an array. In other words, our goal in this session is to learn how to do plotting using array as an input. Before we start with this important topic of plotting, let me illustrate one important feature of Matlab. Let's suppose I have an array of values goes like this. Suppose these are my values in an array, that's x. Now suppose I want to compute the sine of these values. So what I can do simply sine and type sine d. Now this sine d informs the Matlab that the values are in degree, so I can type sine d. So this will give me the sine of each value in x. Sine 0 is 0, sine 30 is 1 by 2, sine 45 1 by under root 2, sine 60 is under root 3 by 2, sine 90 is 1. So this is how we compute the sine of each value in x. So to compute any function of an array, what you can do is just type that function and inside the small braces write the array. And I can assign this array to another array. I can type sine d, and this is x. So this will give me the same array. And with I have stored these values, meaning the sine of each value of x is now stored in another array, that's y. All right. Now let's start with this plotting. Let me clear this screen. CLC, this will clear the screen. And let's suppose I have an array, and let's suppose the array is z, and the values are 2, 6, 3, 8, 10, 12, and 5. Suppose these are the values in my array z. And if I simply type plot z, what this will do, this will plot the values that are in z with respect to its index. Means the value of 2 will be plotted at 1, 1. The value of 6 will be plotted at 1, 2. The value of 3 will be plotted at 1, 3, and so on. In other words, the value of 2 will be plotted at 1, the value of 6 will be plotted at 2, the value of 3 will be plotted at 3, and so on. Let's see. We type the plot z and press enter. And this plots. Now let me switch the screen. So this is our plot. So this is our plot. Now you can see the value at 1 is 2. The value at 2 is 6. The value at 3 is 3. And the value at 4 is 8, and so on. This is how we do plotting in Matlab. All right. Let's start with, let's suppose we want to plot sine wave in Matlab. And let's suppose we want to plot it from 0 to 2 pi. So what we can do, we can say t is, let's define an array from 0 to 2 pi. And do it like this. Then I can do x is sine of t minus whatever is stored in t, we will have sine of that value. Now what I can do, see if I do plot t comma x, what this will do, this will simply erase the previous plot, that is plot z, this will plot. But what I will do, I will open a new figure window. What I will do, I will open a new figure window to do that and keep the previous one open also. So I will do plot figure 2. This will give me another window that you can see. And the new figure window looks like this. There's nothing plotted on this figure yet. Now I will plot. So the name of this figure, before I switch the screen, the name of this figure is figure 2. You can check it. And now let's plot the values by switching back to Matlab. So now I have to plot t comma x Okay, this plots this. Let me switch the screen to show you that. So this is our plot. Now we have plotted a sine A1. Now we can label these axes, x-axis, y-axis, and we can also label this these axes. So to do that, let me switch back to Matlab. So this is our Matlab. Let me label x-axis. We type x label, and inside these quotes we type. Suppose I want to name this axis as time axis. You can put anything there, and similarly I want to label y-axis. So y label. So this will be amplitude axis. And similarly, I want to name this plot. Let's you can put in title. You can say sine wave and enter. You can also turn on the grid by typing grid on. And to show you these changes, let me switch back to Matlab. Figure window, and this is our figure window with time axis, amplitude axis, and sine wave. So this is how we do plotting in Matlab. All right. Now let's suppose we want to plot also cos, and let's suppose this cos we want to plot from minus 2 pi to 2 pi. Let's suppose from minus 2 pi to 2 pi. So we'll create an array of from minus 2 pi to 2 pi. So this is our array from minus 2 pi to 2 pi. What I will do, I'll simply get one more figure window, type figure 3. This will give me one more figure window. You can check. Let me show you that. And this is our figure window. There's nothing plotted on this. Now I'll plot cos function on this. To do that, let me switch back to Matlab. What I will do plot t1 comma cos of t1. So this will plot this cosine function from minus 2 pi to 2 pi. Let me label the axis first, then I will switch to this screen. This is time axis. And then to do y label. So this is y label is amplitude axis. So this is our amplitude axis. Then I can type title. And in this title, I will name this plot, suppose cosine function or cosine wave. This is our cosine wave, and I can turn this grid on. Now let me switch back to this. So this is our cosine function from minus 2 pi to 2 pi. So this is how we do plotting in Matlab and name these plots. Now before I proceed, let me illustrate you one important point that often confuses students. So let me illustrate one important point. Let me do this. Let's suppose we can create an array from 0 to 3 pi. Let's suppose to 3 pi. All right, so this is an array. Then what I can do plot t2 comma sine of t2. So this will plot sine of each value of t2. And to do that, let me switch back to another. Let me first create the figure window. Let's call it figure 4. And you can see there is nothing on this figure 4. So let's plot this function that I can do. I can do plot t2 comma sine of t2. This will plot the function, and then let me switch back to this figure. Okay, now you can see this is a weird sine wave. Now what happened to this sine wave? That's the point I want to illustrate. What happened to the sine wave? Now if you can see what actually this plot function does. Plot function connects the points, means what is the value here? We have 0, then it connects this point to it. So in short, the number of points, it connects the consecutive point, means the which are very near to means it connects the neighboring points by drawing a straight line between each other. What's going on here is I have a few points here, means I have this point here, this point here, this point, and this one. And what Matlab is doing with this plot function, it is simply connecting these points with straight lines. That's why it looks like weird. Now, if I increase the number of points in this T2 array, see T2 array is, let me switch back to Matlab. Let me type T2. You can see there are only 11 points in this T2 array. So to make this the plot better, what I can do, I can increase the number of points in this. So now let me plot this function again on the same graph. Let me switch to this figure window. So this is our sine from 0 to 3 pi now. Now you can check, there is nothing weirdness about this graph. So what happened to that earlier? I had only few sample points in my array, and I plotted those sample points. Means I had very small number of points, and what Matlab does with this plot function, it draws a straight line between two consecutive points. So by how I solved this problem, by increasing the number of points in T2 array. All right, so this is about it. Now, next is how do we change the colors of these graph and style of this? How do we change the style of these plots? What we kept for this, what would we do? We clear this, we type plot, and we write the name of the arrays for which we want to plot. And the next is to change the color and style of this, we type here, whatever we want to type, style, color, and marker, what marker you want to use. All right. So this is how you, if you have to change the color, you can mention that color between these single quotes, and you can also mention the color and marker also. Now to get the information about these marker, style, and what color you can use, you can type help plot function. Help, simply help plot. Now this will give you the information about this, what type of colors you can use. You can see you can use blue color, green color, and so on. Similarly, you can use these different type of markers, and the plots that you can have can be solid. You can use dashed curves also. So you can make these curves look like dashed, whatever you want to, or something like this. All right, let me illustrate this by giving a simple example. Let's clear the screen. All right, suppose we have x, and x is from 0 to, let's suppose 2 pi. Let's suppose we want to go from 0 to 2 pi. And what we want to do, we want to plot this sine from 0 to 2 pi. So this is our sine of from 0 to 2 pi. What I can do plot x comma y. And now I can mention the plot style. What I will do, I will mention color red, and I will mention this means simply solid. And what I will do, I will put circles. This is the marker. R stands for red color. This dash means this is a solid plot, means the curve will look solid. Means that drawing it won't have dashes simply. And let me do plot. All right, before I draw this, let me create one more figure window. Before I do this, let me create one more figure window. That's figure 5. You can check there is nothing on this figure 5. We switch to this. There is nothing on this figure 5 yet. Now I will plot this curve. Switching back to Matlab. So now I can do this. Plot x comma y, and now I will mention this plot style. So I will use blue. Then I will do dash, and I will use the marker as circles or dots. So now I will enter. Sorry, I didn't close this. So this is it's to show to view this. Let me switch back the window. This is our plot. So this is our plot. The curve is solid. You can check this is solid, and this is plotted from 0 to 2 pi, and the markers are circles, small circles. Now let me use another color and a different style. To do that, let me switch back to Matlab. Let me create another window that I call figure 6. And on this figure 6, what I want to plot the same curve, but different color, and I want to dash. This time instead of circles, I want to have diamonds on this. Where the plot style should be diamond. Okay, enter. Now I'll switch back to this to visualize this. That's how our curve looks now. So this is dashed, and the markers that are there are diamonds, diamond shapes. This is how you can make these plots to appear on your Matlab screen. All right. So this is how we can change the color style. There are different color styles again to see what colors you can use and what type of markers and this type of curves you can have. Type help plot, and this will give you the information about these. You can see this is the information listed. So you can use colors like blue, green, red, and you have to use just these symbols. Similarly, if you want to make any marker on this, you can type point means dot, or the circle means O, you have to write O, X cross means X, you have to type there, and so on. Similarly, if you want your curve to be solid, dotted, or dashed, you can use these to do that. All right, this is about how to do coloring of this plot. Now next, what I want to illustrate, if I want to do multiple curves on the same figure window, let me create a figure window first. And let's say this is figure 7. I hope this is visible to you. I'm still on that. Sorry, I'm still on that figure window. I haven't told you that what I have done. Let me switch back to this screen. What I said previously, I said to get any information about this plot or which colors you can use, you can type help plot, and this will tell you that which colors and which markers and which this color and this type of curves you can have. All right, so if you want to have red curve, you type simply R. Then if you want to have crosses on that, you can write X. And suppose you want to have a dotted plot, and this will give you the dotted plot. All right. Now, what I want to do next, can I have multiple curves on the same figure window? So to illustrate this, let me create a first a figure window. This is our figure window. All right, let me check. See. There's nothing on this figure window yet. What I want to do, I want to plot both sine and cos wave on this curve. Can I do that? Yes, I can do, and that can be done two ways here. That can be done. Let me illustrate both. First, let's suppose I want to plot these curves from -2 pi to +2 pi. Let's suppose x is from, let me use t instead of x, -2 pi to 2 pi. So this is our axis. Now what I can do simply plot t comma sine of t and enter. You can see now I have a sine wave there. I have sine wave on this figure window. But I want to also plot cosine wave on this. For this, I can do this two ways. As I said, I can do this two ways. To do that, what I can do, I can type hold on, means this will hold the previous curve, previous plot. And now I can type plot t comma cosine of t, cos of t. Now let me switch back to this figure window. You can check I have both the plots on this. All right. Now, if you want to name these plots, for example, you can type a function on your Matlab. You can type a command on your Matlab that's called a legend. If you want to name these plots, you can name it, for example, sine wave. And I want to name it cosine wave. So these are so to name these plots, what you can do, you can write legend, and inside this small quotes, you can write this. Now let me switch back to this figure window to show you these. All right. So this is our figure window. All right. So and there with their names. Now, same thing means to have multiple plots on the same curve, on the same plot. I can do this another way. Instead of using hold on, I can do an array. So to do this, I will create another figure window. Let me call it figure 8. So this is figure 8. Yeah, as you can see, there is nothing on this figure window yet. Figure 8. And there is nothing on this figure window yet. You can check, there is nothing on this figure window yet. Now what I will do, I will plot both sine and cos on this, but using this plot function only once. What I will do, plot x comma sine, sorry, t comma sine t comma t comma cos of t. So this will plot t and sine, then it will also plot on the same graph t and cos t. Enter. Now you can check. I have both the plots on this figure window. All right, this is our figure window. Now to change the style of these curves, what you can do, go back to this previous command and type, suppose I want to see this sine curve in red and I wanted to view it in dash form and something like this. So this is plot style. This what I put inside these small quotes. This means how you want to view this curve. The curve will be red and this will be dashed and the markers on this curve will be diamond shaped. Similarly, what I want to view this cos curve in blue, and I want to suppose view it in dash and markers on this curve will be circles. Now I can press enter and let me switch back to this. Okay, I hope this is visible. All right, so this is our, so you can check it, although the markers are not visible. Why are not these visible? Because I have used lots of points in this. So let me switch back to my Matlab and create less number of points now. So let me switch back to Matlab. See, I have in T, I have lots of points. Instead of these number of points, what I can do, I will use less number of points now. And now I will plot. You can check. Now these are the curves. So now the one is sine and another is cos. To name these plots, what I can do, I will use legend and then I will type sine wave and another I will name cosine wave. So this is sine wave and cosine wave. You can check it. So this is our sine wave and cosine wave with the names on it. So this is how we do plotting in Matlab. And you can also turn on this grid on to make it look more attractive. What you can do, you can do grid on, and you can see now the grid on this figure window is also turned on. So this is how we do plotting in Matlab. All right. Next, what I want to do, I want to plot any function. I want to plot any function. Now to close these windows, what you can do in Matlab, to close all these figure windows on any Matlab window, except this command window, what you can do, you can simply type close all, type close all. This will close all these windows that are open in Matlab, means these figure windows will be closed now. You can check, there will be no window that's not closed yet. All right, so now what I want to do, I want to plot a polynomial. Let's suppose we want to plot a second degree polynomial. Can I do that? Yes, we can do that. Let's suppose we create an array of numbers from -2. Suppose we want to plot this polynomial from -2 to 2. So I will create an array from -2 to 2. Then what I will do, I will create another array of this polynomial. So suppose my polynomial is 2 x square. This means element-wise square of x. This dot and this cap notation means element-wise square. Whatever is in x, do squaring of each element. in that x. And then I can do plus x. And let me use fifth order polynomial plus x minus 1. So this is our x. Close this, then I will say plot x comma y. And let me label it first. X label is values of x, and y label values of x is a polynomial, and title I can put there. Title I will put plot of 2x raised to power 5 plus x minus 1. And I can turn on the grid, type grid on, and now let me show you the plot. The plot looks something like this. So this is our plot. This is the plot of this polynomial 2x raised to 5 plus x minus 1. So this is the plot. All right, next I want to show how you do polar plot in Matlab. To do polar plot, what you do simply, let me switch back to Matlab. So this is our Matlab. Let me clear the screen. To plot the polar plots in Matlab, what I can do, I plot theta, I write value of theta and r means radius. This is how we do polar plot. So I must have the value of theta and r first. Let's suppose instead of theta, I will write x. X is from theta or x is from 0.01 to 2 pi. So this theta is varying, or x is varying from 0 to 2 pi. All right. Now what I want to do, I want to do polar. Means polar plot. This will create a plot that is polar sine of 4x. So this is our polar plot. And let me show you how this polar plot looks here. This is the polar plot from 0 to 2 pi. And I have created a sinusoidal values of that. This is how the polar plot looks in Matlab. All right. Another important plotting that you can do is the area plot in Matlab. This is important for several people. So let me say this time the theta or x varies from 0 to 4 pi. Let me suppose the x is varying from 0 to 4 pi. And let's suppose we create an array of this sine of x. Now what I will do area. So this will give me the area, whatever area is inside between this sine curve and x-axis. So I'll give sine. Let me switch back the screen so you can check it now. So this is the area plot in Matlab. So this gives you the area between the sine curve and x-axis. All right. So this is how we do this plotting in Matlab. Now another example for this polar plot. Let's do one more example of this polar plot before we move to the discrete time plots. Let me switch back to Matlab. All right, so let's clear the screen. Suppose my theta or x is varying from 0 to 2 pi. Suppose this is varying from 0 to 2 pi. And suppose there are 100 points between 0 and 2 pi. What I can do, okay, I didn't put semicolon at the end. It is displayed the results here. Suppose my r is, let's suppose my r is 3 times cos. I'm defining an arbitrary function, and argument is, or theta is x by 2. no matter what I want to do, I want to square off each this plus x. So this is my radius or simply r. If I do polar of this x comma r, I will have a plot that looks something like this. As you can see, the radius is decreasing as this theta increases. All right, let's now discuss how we do discrete time plots in Matlab. So we do discrete time plots in Matlab. Let's suppose we want to plot a discrete sine wave in Matlab. Now for this, Matlab has an inbuilt function. Let's suppose we wanted to create this from 0 to 2 pi. So we want to have this from 0 to 2 pi. This is our time axis. So y is sine of x, means create the sine of each value in x. Then what I can do, stem x comma y. And I can put the x label, y label, and title of this plot. Let me put on the title. Let's take into yourself. Discrete sine wave. This is our discrete sine wave. Let me switch the screen. You can check. This is the discrete sine wave from 0 to 2 pi. You can check it's increasing and decreasing, goes like down this. So this is how we do discrete plots in Matlab. All right. Now, before I switch to the 3D plots, in Matlab, how we do 3D plotting in Matlab, what I want to discuss here is how you can edit these plots on the figure window itself. What you can do, you can click on the view option and click on property editor. Now this will give you the options to plot this, to edit this figure window itself. Okay, let me share the screen again. And you can check it. Now I can increase the size of these. See the size, current size is 0.5. I can increase it to 2. I can change the color, and the color is pink now. So you can increase the size. You can put a dash it like this. So this is how you edit this. All right, you can put a grid line also there using this property editor, and you can label this. This suppose is time axis. So you can edit these plots on the property, this figure window itself. So this is my amplitude axis. All right. So this is how can do the editing of these plots on the figure window itself. All right. Then you can switch back, and it will look like this. So all right. So let's move to the 3D plots now. Let's move to 3D plots now. All right, so let me clear the screen. So let's see, let's suppose we want to plot this Gaussian, two-dimensional Gaussian curve, right? Let's see how we do that. What we do in Matlab to do that, let me share the screen. Now to create a three-dimensional Gaussian curve, what should I have first? I should have a two-dimensional grid of points. So I should have a two-dimensional grid of points. So if this is my grid, and these are my points, this is my grid. So for each point in this grid, I will create a Gaussian function, this two-dimensional Gaussian function. So for each point in this, what I will do, each point I will compute the Gaussian. So first, what is the first requirement is create this grid of points. What I will do, create this grid of points in Matlab. Then for each point in this grid, what I will do, I will compute the Gaussian. For each point in this grid, I will compute a two-dimensional Gaussian function. That will be my third dimension. So if this is my two-dimensional space, then what I will do, I will compute the Gaussian value, two-dimensional Gaussian function for each of these values, and that will give me the third dimension. So the plot will be three-dimensional now. Now, first job is to compute this two-dimensional grid. So let's do that. Now, to do that, what I will do, I will go back to Matlab and create this grid of points and create this grid of points. So let me share the screen. So now I'm on Matlab. So what I can do, Matlab has an inbuilt function. Matlab has an inbuilt function to do that, and the arguments are like this. So the function is mesh grid, and this will give me the grid of points. And I want the axis to vary from suppose -2 to 2, and y-axis suppose I want to vary from -3 to 4. This number of points. So this will create a grid of points in two-dimensional space, while x will be varying from -2 to 2, y will be varying from -3 to 4. So this will create a grid of points, and then these points will be stored in x and y. Now what I will do, next I will define another variable z, and I will compute the Gaussian function. If you remember the Gaussian function, let me switch back the screen. Now the two-dimensional function looks something like this. Now two-dimensional Gaussian function looks something e minus x squared by sigma square plus y squared by 2. And sigma is standard deviation. If you have studied random course, this is standard deviation there, and there is one by there is some constant also here. That constant for time being, let me use this, and let's suppose sigma is 1. Let's suppose sigma is 1. Let me switch back to Matlab. And this is my Matlab. Now I will compute this Gaussian function. So there is minus at outside x. Now what does it mean? This dot cap, this means element-wise square of each point of x plus element-wise square of each point of y. And this will compute that this Gaussian function of this two-dimensional grid, and that will be stored in z. Now what I can do, plot 3, and do x comma y comma z, and this will give me the three-dimensional curve that looks like this. You can check, it's a three-dimensional plot. So this is a three-dimensional plot. All right. So this is our three-dimensional Gaussian function. Oh, sorry, two-dimensional Gaussian function. So this is our two-dimensional Gaussian function. Now there is one button that's called the rotate button. I don't know why is that not visible on me. Share palette. I don't have to view. There's one button by which you can rotate this graph. That's, I don't know what's that called. It's called rotate 3D. That's this. So you can rotate this. Yes. So you can rotate this three-dimensional graph and view it. So this is our three-dimensional graph. This is our two-dimensional Gaussian density function. All right. Let's do some more examples in three-dimensional Gaussian plot. Let me switch back to Matlab, and let's do some more examples. Let's suppose we want to compute a function. So this is when you use plot 3. Plot 3 means three-dimensional plot. Now let's suppose we want to plot this function. And let's suppose we want to plot now this function. Suppose I want to plot f of y is super. How to do this? Now see, there are two coordinates of this, x and y. So my first thing is I must have a two-dimensional grid of points. Then for each of these points, I will compute this f because my arguments are x and y. So each point in this grid, I will compute this f, and that I will store in fr. Let's see how we do this in Matlab. Let's see how we do this in Matlab. Let me switch to Matlab. So let's again create this grid of points. For this, I will use again the function mesh grid function to create this two-dimensional grid of points. Let me do it in a different way. Let's suppose x is from -1 to 3, and let's suppose y is from -3 to 3. All right. So this is now I will create x and y. The grid is now stored, means the two-dimensional grid is stored in now capital X and capital Y. So this is mesh grid x comma y. So the two-dimensional grid points will be stored at capital X and capital Y. You can view what's x and y. So first value of x is -1. First value of y there is -3. Similarly, the second value of x is 0, and the value of y on that axis is -3. You can check. So this will be a grid of two-dimensional grid of points. All right. Next, what I will do, I will create z, capital Z, then create capital X square. Since I have to do element-wise this square, I will put dot there. All right. Now, instead of using plot3 command, I will use a different three-dimensional Matlab command that's called a mesh x comma y comma z. So this is my plot, and my plot looks something like this. Let me share that with you. And this is our, let me first close this property. All right. So this is our three-dimensional mesh plot. And if you want to rotate it to visualize it better, if you rotate it, it looks like something like this. So it looks something like this. It looks a two-dimensional kind of a sheet. Right. And this is in 3D. And the plot is in 3D. Another three-dimensional function that you can use to plot these, to have these three-dimensional plots is surf command, like mesh. That's also, instead of using mesh, what I will use. So let me change that first. Let me repeat this mesh again. So what I will do, I will use more number of points in these now. X is 0.1, 2. Then I will create again this mesh of these. Then I will do mesh. It's okay. I have to execute this first. I have to execute this function first, then type mesh command. Now you can see the mesh plot looks something like this. The mesh plot looks like this. Okay, now you can rotate it using the rotate function. So this is our mesh plot of this x square plus y square function. So this will look a parabola. This will look like a parabola. So please visualize it and rotate it yourself. This will look like a parabola in three-dimensional space. This will look like a parabola in three-dimensional space, or a parabolic dish antenna. All right. Let me switch back to Matlab and discuss if we use a surf instead of mesh. So what I will do, I will use surf instead of this mesh. That will do the same. And let me switch back the screen. So this is my plot. So this is my plot. This is a two-dimensional parabola. To view it better, you can use more number of points for x and y, this will look like a parabola. This will look like a parabola. To view it better, let me change the range of this x and y. Let me change this range of x and y from -5, 5, and let's suppose x varies from also -5. Then I have to change the discrete again. Then I have to compute this function again. What I will do, I will plot the self. Now I can switch back the screen, and you can see it looks like a parabola. Now it looks like a parabola. You can label these x-axis, y-axis, and z-axis. So now you can say x label. You can say x-axis. Similarly, y label you can name. So give you y label, then you can say z-axis, or you can say f. So z-axis. Now let me share that again. You can check. The plot looks something like this. We can rotate it again, and it looks like clearly this. What is this? A parabola now. This looks like a parabola. I hope it's visible to you. You can see it looks like a parabola now in 3-dimensional space. So what I did, I simply changed the number of points to make it look attractive. I simply changed the number of points. Okay. Now one more 3-dimensional plot before we end this session. What I can do the stem plot, 3-dimensional stem plot. And I mean stem function is used to plot, discrete function is in MATLAB. So stem is used for to plot discrete time signal is in MATLAB. Now to do that, what I will do, I will this time create a 3-dimensional stem plot. For this, what I will do, I will write theta. This is my variable, and let's suppose this varies from 0 to 2 pi. All right. So this is my x. Now suppose x is sine of theta. Y is cos of theta. And then z is theta itself. All right. So what I can do stem t, same way like plot 3. This will be x comma y comma z. And the plot looks like, before I switch to this, let me use that. Let me label the axis as well. And y label, y axis, then z label. And z. All right, now let me switch to the plot, 3-dimensional stem plot, and you can see this is a 3-dimensional stem plot. You can rotate it. All right, this is the plot of this function. So this is the 3-dimensional plot of the function with the values. All right, now I showed few plots in MATLAB. There are several options to have these 2D and 3-dimensional plots in MATLAB. For this, if you want to see the others, you can refer to the documentation. Now, before I end this session, I want to illustrate one very important plot that's very useful for ECE and especially for data science people. This plot is very, very important for data science people, and that plot is referred as scatter plot. Now, to scatter plot, what I'm going to do, I'm going to take a simple example. What I'm going to do, I'm going to have my x-axis varying from 0 to 3 pi. Let's suppose my x-axis varying from 0 to 3 pi, and I want to have 200 points on. Sorry, what I did wrong. Okay, linspace. I wrote the spelling of this linspace wrong. All right. Now next, what I'm going to do, I'm going to take cos of these x. So this will compute the cos of whatever is in x, it should compute the cos of x. But what I want to do, I want to add noise to it also. I don't want to simply plot x. This, see, this I can do very simple. This, let me rewrite this, and so I don't want to simply plot x comma y. That you can see looks like. Just a second, let me share this. Okay, that's shared with you. So you can check, that looks something like this. So it's a cos plot, but I don't want this plot. I know already how to plot this. I want to add noise to it also. So what I will do, I'll write y is cos of x plus some noise. And let's suppose that the noise is uniformly distributed noise. And let me, how many points are there? 200. So I will add 200 points from this array, and this will be a noisier version of this cosine function. Now, if I see the plot, you can see the plot looks like something like this. Now, this is my plot. This is a noisier plot that you will have. You added noise to it, means you added, this was your cos actually. So suppose this is your message signal. Now you have added noise to it. All right, but I don't want this plot. I want to show you a different plot here. What I want to do, I want to create a scatter plot of these points. That means scatter plot of these points. So I type scatter x comma y, and the plot looks something like this. This is the scatter plot of these points. You can see now you can change the color, and to view this, for this you can how to view these points, means how you scale these points with different colors. You can view, for this you can use the Matlab documentation. But I wanted to just illustrate it. This is very, very important for communication and people who are studying today data science and artificial intelligence, meaning machine learning. This is very, very important plot for those guys. All right, let me end it here. I hope you will like this video, but the most important thing is, if you didn't understand, please refer to the documentation, and you can see the help of these different functions that I used from the Matlab documentation. All right, let's end it here.